In this video, I am going to demonstrate how to convert a normally distributed variable into a variable that follows standard normal distribution. Let us get started. First, we will generate some normally distributed random numbers. To do that, we need to go to data, then go to data analysis. Then we need to click random number generation, and then we need to click OK. I want random numbers for one variable. I need 10,000 random numbers, and I want the random numbers to follow normal distribution. I want the mean of those random numbers to be 5 lakh and standard deviation to be 4,000. I want the output to appear in this sheet itself. So I need to specify the output range. Let us say I want the output to appear starting from A2. Once I have filled all these things, I can now click OK. And you can see I have got 10,000 random numbers. From count, you can see it is showing 10,000. So it basically means Excel has generated 10,000 random numbers. Let us give a name to these values. That means let us say these are different values of variable X. So X is a variable which is normally distributed. Now we can verify whether X is normally distributed or not by simply generating the descriptive statistics and plotting the histogram. So let us quickly do that. To generate the descriptive statistics, we can go to data, then data analysis, then we can click on descriptive statistics, then we can click on OK. We can just specify the input range. So input range will be from A1, then Control Shift down arrow. And I need to click labels in the first row because the first row is a label, right? And let us say we want the output to appear in this sheet itself, and we have to specify the cell where we want the output to appear. Say for example, we want the output to appear in D1. Then we have to click on summary statistics, and then we can click OK. So we have got the descriptive statistics, and we know that for a variable which is normally distributed, skewness and kurtosis both will be very close to 0. And you can see that both skewness and kurtosis are very close to 0. So we can say that X is by and large normally distributed. You might think, why is this sum value displayed in this way? You just need to select this cell and format this cell by pressing Ctrl 1 and change this category to number. Now you see the problem is sorted. So next thing what we will do, we will quickly generate the histogram for X. So for that again we have to go to data, then data analysis, then have to click on histogram, click OK. Again we need to define the input range. So A1, Control Shift down arrow, and we need to select the labels because the first row is the label. Bin range we have to keep blank, and Excel will take the bin range automatically. Let us define the output range. Let us suppose we want the output to appear somewhere in G1, and we also want the chart output. So let us click on chart output. Once all these things are done, let us click on OK. Now you can see we have got the histogram. I can just expand this histogram little more so that it becomes little bigger. We can delete this frequency part to make the histogram bigger, and you can see the histogram takes the shape of a bell-shaped curve, which basically indicates that X is normally distributed. Now what I will do, I will just convert X into a standard normal variable, and let us call that standard normal variable Z. Right. Now how do I convert a normally distributed variable into a standard normal distributed variable? Simple. For that the formula is X minus mean of X. So mean of X is in E3, and I'll give an absolute reference for E3. So A minus mean of, so X minus mean of X divided by standard deviation of X. So standard deviation is in E7. I will give absolute reference for E7 as well. Why do I need to give absolute reference for mean and standard deviation? Because for all values of X, mean and standard deviation are the same numbers or same values, right? So once you have entered this formula, press enter, and you can just double click on this plus sign to get it replicated for all the other cells in this column. So done. Now we have converted X into Z, where Z follows standard normal distribution. Now we know that a standard normal distribution will have mean equal to 0 and standard deviation equal to 1, right? And we can cross verify these things with the help of descriptive statistics and histogram. And we can also cross verify that a variable which is following standard normal distribution will have skewness and kurtosis very close to 0. So let us quickly generate descriptive statistics and histogram for Z. So for that we need to go to data, then data analysis, then we need to go to descriptive statistics, click OK. Now my input range should be B1, Control Shift down arrow. Column should be ticked, levels in the first row. We have to define the output range. Say let us want the output to appear in D17. Summary statistics should be clicked, and click OK to get the descriptive statistics for Z. You see, descriptive statistics for Z, we are getting mean is equal to 0. In fact, this number is 0. You can just format this cell, Control 1, change it to number, click OK. So mean is 0, standard deviation is 1, and skewness and kurtosis both are very close to 0, right? So all the conditions are met. Now again, this sum value can be formatted to a number. Now what we can do, we can just plot the histogram for Z. Let us again go to data, data analysis, histogram, click OK, define the input range, B1, Control Shift down arrow, leave the bin range blank. Excel will take the bin range automatically. Label should be ticked. I need the output in this sheet itself. Click the chart output and define the output range. That means specify the cell where you want the output to appear. Suppose I want the output to appear somewhere in J18. Okay, so once all these things are done, click OK. So it will give you the histogram for Z. You can just expand it a little bit, delete this frequency part, and you can see the histogram of Z, which is a standard normal variable, and you can see the histogram of Z is also a bell-shaped curve. So all the conditions are fulfilled. So this is how we can convert a normally distributed variable into a variable that follows standard normal distribution. Hopefully this part is clear and you have understood. Thank you.